Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to NPTEL online certification course on research methodology for planning and architectural studies. Today we are going to discuss a very important topic, and many a times in our previous lectures we have discussed somewhere about the hypothesis. Now what exactly the hypothesis means and how to test it. So there are certain sort of testing procedure of hypothesis, but before that also it is important to know how to formulate the hypothesis. Is it mandatory for any research or it is not mandatory? If it is mandatory or if it is relevant to your research topic, so how to form or how to formulate the hypothesis in a correct manner so that you can test it with available statistical method, and then you can bring out some meaningful observations. So with that we will be discussing this particular hypothesis testing in this current lecture, lecture number 36. So out of this lecture our aim will be to understand what exactly hypothesis is and then how to formulate the hypothesis. Is there any particular aspects that you need to follow, or else you can say in short that what are the different criteria that you follow to form a good hypothesis. Then at the same time when we talk about hypothesis, we also need to understand certain terminologies like concept of confidence interval, concept of significance level, and also something very important, many a time we use it, like null hypothesis and alternative hypothesis. Also in this case I will show you in a very brief manner about the hypothesis testing process, and then another important aspect about the type 1 and type 2 errors of hypothesis testing, and then we summarize our understanding. Let us understand what is hypothesis, and this is something it is not a new terminology that is we are discussing in recent times. So it started with a Greek word hupo and then thesis, and then initially it was mentioned as a hypothesis, and then in late Latin it is referred in late 16th century as hypothesis. So what exactly it is? It is nothing but a guess made to test logical and empirical research outcome. That suppose you are collecting some information for certain phenomena and you assume that okay, overall out of the collected information the final output will be something like this. It is a guess. Say for example, in a particular study area you are capturing the socio-demographic information, and for this particular purpose to understand it very easily, let us assume that you are collecting the income of the respondent, and then your hypothesis is something that you make a guess that in this particular area the average income will be some x amount, right. So you will just try to check that okay, even if there are certain sort of variation in the income level, but overall on an average it will be like this. So average income, say for example average monthly income is around say 2 lakhs rupees for a family, right, and then it is something somewhere you can get it's more than that or less than that, but average monthly household income is say this 2 lakhs rupees, that is your hypothesis. Now definitely whenever you have those kind of information, and null hypothesis is something where you assume there is no such of variance and it is exactly the same. But the moment you get certain different value, right, so then probably your null hypothesis will not be accepted, and then you can establish the any other alternative, that average income is more than that, average income is less than that, or average income is to a particular value. So in such cases, like definitely we can have different sort of alternative outcome for a research that you conduct or some analysis that you will conduct with the primary information or secondary information. Now significance of hypothesis, definitely in this case hypothesis assist in explaining the research problem and objective into a comprehensive explanation or predicting the results. Also it is derived from the research problem itself, it can be from literature review, or it can be something based on a conceptual framework. Sometimes you can also compare your findings with the findings available in literature. If that kind of data set available, you can compare that, and it will help, definitely it will help researcher in a great way in thinking and giving focus on the important facts of the problem. Now for a particular city, you take example of water supply. Now there are some standard where we all know, probably we have studied in some infrastructure planning class or some other water supply engineering class or something like building science or some planning class, that as a thumb rule per capita water supply it's to be calculated like 135 LPCD, liter per capita per day. Now this is just assumption, but there will be some variation, definitely there will be variation, maybe in some cases the actual supply somewhere maybe little less, little more, but this is something on an average it is aiming to supply 135 liter. But now for a particular city, if we are interested to understand this particular variation, that is there any variation actually observed in terms of total water supplied, or it is actually the same, or maybe in that case you can take this example in other way, that you are not looking at the supply perspective, you look at the demand perspective, or you can say consumption point of view, that per day per capita how much they are consuming, right. So there we can assume, or we can make certain null hypothesis that okay, there is no such kind of variation in terms of water consumption in that city, per capita water consumption. But if your result will come up with something, so there are certain sort of test statistics that I will discuss in next few slides. You check it, you check its statistical significance. There are certain measurement like you have t value, you may have z value, you may have p value, depending on the type of data and what you want to estimate. So statistically then you establish that okay, in this particular city probably the assumption of this, there is no difference in the consumption pattern, either will be valid, either it will be proven as true fact, or maybe it is not the right fact. So then you can definitely accept that it is something behind, or maybe it is something not exactly 135, it is below or above that particular value. So in this particular slide, let us understand that before you formulate any hypothesis, that you also stress upon the research questions, and then you can check your hypothesis and what kind of hypothesis you will formulate. So it can be something of descriptive in nature, it can be something that we would like to know the difference, or maybe sometimes it may be the relationship or the association. So this is very important first to think about those kind of research questions. So here I am taking one example which is not from architecture or planning domain, but for easy understanding we are talking about something related to the batsman in cricket. So, if we go for descriptive, the question is who is the best batsman in the world, right. In state of difference, that which team has the best batsmen in the world, and then the association is, does batting position or batting order in a particular match affect the batting performance. So, in this case it is all related to a cricket and related to a batsman, but in this case definitely what we are trying to focus on is basically the performance. So, for first one it is nothing but collect all the batting average of cricketers. So, maybe you can take one day match or T20 match or maybe test cricket, depending on that you just calculate that whatever the indicator like average that score per match or maybe the strike rate. Now, this is for the first. For the second, it is something that you collect the batting average for all cricketer and then you sort by the country. So, definitely here you can compare that okay, the best batsman may be whatever XYZ is from this country. Now, in the last part where we are trying to get certain association, in this case we are going to collect the batting average of all cricketers and then sort by the batting position, that whether it is opener, in third position, fourth position, etc., and try to see, right. Now, next we have something to that hypothesis formulation. In this case, this hypothesis formulation can be done based on certain discussion with expert, so that the clarity of those statement you can validate. We can also do it based on the existing data gap. It can be like something based on the previous study and we try to revalidate because there are certain change in certain parameters. So, we can revalidate it, or it may be something just as personal investigation, we would like to get some new information or something, try to say a new relationship whether it exists or not, whether that particular value is acceptable or not. The hypothesis is a testable statement about the relationship between two or more variables. A proposed explanation for some observed phenomena is actually the definition. Now, in this case definitely whatever we are stating as the result, or maybe you can say the hypothesis, or normally whenever we state a statement that there is no change and there is some kind of same value, like whatever data you will collect from sample 1 or in sample 2, and in that case you try to see the changes and then null hypothesis that there is no change. Similarly, the example I have given, that income level in a particular city, that there is no change in the income, monthly family income for the study area. So, that is your null hypothesis, and anything beside that is alternative. Now, characteristics of a good hypothesis: there should be some sort of empirical references, it should be conceptually clear that what you want to measure, it should be very specific, there should not be any ambiguity in that measurement, and in this case definitely we should also think about what could be the possible test of that hypothesis. In some cases you can apply certain test statistics, somewhere it is not. Say for example, we will discuss and mention some of them, and definitely you can go through any statistical book, you will get some more about those kind of test statistics. Say if we want to compare something about the mean of any sample or a single sample, or maybe it is like two sample, we can go for some t-test, right. What is t-test? I will come to that in next few slides. If you want to understand the difference in variance within two groups or maybe within the groups, so you can go for some sort of analysis of variance or ANOVA, and there as a test statistics you can use the F test. Like that, in many way you can go for some kind of chi-square test. There are other n number of tests available, right? And then definitely the hypothesis should be something related to the body of theory, and definitely in that case, if you want to like challenge any theory or you want to contradict a theory, there should be enough reasoning for that. Now, let us understand the normal distribution, because most of the tests that we are going to follow in most of the cases, like we go for a Z test, or maybe we can say that T test. So, that will depend on this kind of distribution, but definitely when it is like some other distribution, the test may vary. So, this is something where you can say that earlier also we have discussed it, where we are interpreting the data. If your collected data is having certain distribution, we can check it. So, whenever it is normal distribution, so definitely whenever you see the top of this bell shaped curve, so this is nothing but the central tendency of data. Okay, so that is the mean. The moment it will go on the right side, it is like the values are more than the mean, and then when you go on the either side, it is value less than the mean. So, say example of any performance of any particular class. So, definitely some students will score very high marks, some student may get very low marks, but when you take a mean, so it will be some value where you will get maximum students are in that. So, it is actually for a large class you can get this, but definitely this is just one example. In a class, maybe all of them can score very good marks or all of them can get very poor marks subject to that particular performance, but in general this is actually you can see. Or maybe the speed of the vehicle, you can take any phenomena, you can always check that which kind of distribution they can fit, and for any statistical book you refer, you will get about different distribution and other characteristics of that, where like you can test the distribution of your collected information and the best fit distribution for your data. So, the frequency of occurrence reduces away from the mean. So, that is why you can see that in this case nothing but you have very less values will come in these two position. Now, in this case the significance level, where I just discussed, the significance level is the predetermined threshold value used to determine the statistical significance of a test, and also it will represent the probability of rejecting or accepting the hypothesis. So, in this particular normal distribution, definitely the total area under the curve is 100%. So, whenever you are testing any phenomena, so there definitely we take certain margin of error and some confidence interval. So, normally we test in planning and architecture, those kind of research we test it at 95%. So, the values which are coming out of your test statistics, we check that whether those value or those probability of having it within this 95% of this area. So, whenever it is something like you say confidence interval is 95%, and for you can say the normal distribution. So, you have like definitely both the side, you have this right side at positive and left side as negative. So, we are leaving 5% like that particular part as the significance level. So, any value where the significance is the value for test statistics is less than 5%, that means there is high chance they are coming into the confidence interval. So, this is the interpretation. Like normally in statistics we measure those kind of significance level or p value, and the value is taken the threshold value is taken as a 0.05 or which is nothing but 5%. So, that means any particular test statistics, if the corresponding p value is more than that, say maybe it is 0.06. So, even it is something which is like more than 5%. So, then in that case definitely it is not in this particular confidence interval, but at the some in some other particular results or maybe in other study, you may find those kind of significance are test at 10% significance, or in that case you can say alternatively that those values are tested at 90% confidence interval, right. So, we have to understand the content of the research and then how much significance level we will set. So, maybe in some cases in some medical research or medicine research, maybe we can also think about the 1% significance level or 99% confidence interval. Now, in this particular case definitely whenever the value like you have this 5% and if it is something a two-tailed test for both the side we are testing. So, we just divide this value as alpha by 2 either side, right. So, that is why it is 2.5%, 2.5% on either side. Now, similarly whenever your value is within the confidence interval, that is also referred as your acceptance region of the value that you get from the test statistics, but if it is beyond that, it may be on this side or on the other side. So, it will be on the you can say the rejection zone. Now, say for example, in this case you have the mean which is basically you can say the mean of population data, and whenever we test it in a sample. So, in that case probably the population mean or the sample mean ideally they should match, so that it will be representable, but we can see in this case the other means like where you have these 3 brown dots, they are within the acceptance region. So, we can say that okay, it is same. So, both means like in this case all the means are same at 5% significance level. But at the same time if you find the means calculated mean value and other things, so in those cases the test statistics represent that they are outside the confidence interval zone. So, then in that case the means are not same. Okay. Now, this is already I have mentioned that for any particular hypothesis testing, so there will be some test statistics or it may be the p value. In this case whenever you have your critical value, okay, something more than calculated value. So, in this case like you have the acceptance region. So, in this case definitely whenever the critical value is like within this particular boundary, you will accept it. Wherever you say that the rejection region where your critical value is less than calculated value, or you can say the calculated test statistics is more than critical value, then we have to reject it. Say for example, like if you consider z value or t value. So, in both the cases if you take 95% confidence level, so the corresponding z value is 1.96 in two-tailed test, and at the same time t value is also the same 1.96, right. It can be plus minus depending on the you can say the relationship with those kind of estimate. But say for example, your t calculated is something 1.70, okay, plus or minus. So, that means your t calculated is less than t critical, which we will get from a t table or z table that are available. Then we can say that in this particular case we cannot reject the null hypothesis, or in that case we can say that it will be something definitely we cannot reject, right. Next part is that if suppose the t calculated value is something 2.10. So, as because t calculated is greater than t critical, so we can say we can reject the null hypothesis. And in all this case, null hypothesis is something where we consider that there is no change, in mean, or there is no change in variance between two particular variables, or maybe two particular groups which are in consideration for our study. So, this is something about testing it based on the test statistics, like the value, calculated value should be more than the critical value, then we will reject that particular hypothesis. If it is not, then we will accept, maybe we do not use the word accept, normally it is called as fail to reject the null hypothesis. Now, critical value changes based on the significance level and number of variables, because in some cases it will also depend on number of variables, and based on that you will find different kind of values in the Z table, T table, F table, etc., or chi-square table, and then you have to take those value for the comparison. Now, let us understand some key terminologies. So, test statistics is something that I have just mentioned. So, in this case, test statistics measures the difference between observed and expected data, such as T statistics in T test, F statistics in ANOVA I mentioned, and J statistics in Z test. P value, it is another important terminology and which represent the significance level. So, p value indicates the probability of obtaining such result by chance, the preferred to be less than the significance level to reject the hypothesis. So, as I already mentioned that if you take 5% significance level, which is the value is 0.05. So, your p value should be less than the 0.05 to say that okay, we are now okay to reject the null hypothesis. Degrees of freedom are the maximum number of logically independent values which may vary in data sample, usually one less than the number of items within that particular sample. So, if there are total n number of variables that you are going to measure, or n number of samples that you are going to measure, in those cases you calculate it like n minus 1. Hypothesis testing procedure, in this case definitely first you have to state the null hypothesis, which is represented by H0, and then alternative you can write HA, but it can be alternative in any number. If it is one alternative, so H1, if there are many, so H1, H2, etc. Specify the significance level, then decide the correct sampling distribution, so that you can take the right test, whether it is normal distribution or T distribution. Then select the sample and collect the data, then calculate the probability, the p value, and then in this case if you find the p value is less than the significance level, normally we take 5% that I mentioned, we reject. If not, we can say like in this case fail to reject the null hypothesis. So, in this case the null hypothesis is a statement of no effect or no difference, where alternative is there is some kind of statement which contradicts the null hypothesis. Alternatively, when you go for testing it with the test statistics, in this case it is something you need to understand, it is not the previous one where your calculated p value should be less than the critical value or significance level to get it rejected for the null hypothesis situation. Now, here in this case the test statistics should be greater than the critical value to reject the null hypothesis, and if it is less than the critical value, we will fail to reject the null hypothesis. Now, coming to this part, which is very important, type 1, type 2 errors in decision making on hypothesis. So, this is the table, let us understand in that in a clear manner. So, I will try to explain it with example as well. Say for example, you have certain null hypothesis and which is actually true, then if you reject it knowing that that particular hypothesis is true, but then you reject it. So, that is referred as a type 1 error, and then it is also something where we can say that false positive, where the probability is calculated with alpha. Then the second case where you find that okay, the null hypothesis is true and you are accepting it, and in that case we are writing fail to reject null hypothesis because it is actually true. So, that is a correct decision, and then in that case the probability is measured just 1 minus alpha because total probability is 1. But in some case it may happen that the statement or out of your analysis you will find that the null hypothesis is actually false, and then as because it is false and you are rejecting it, so you are making a correct decision because it is false. So, then there is no logic to accept it. So, you are making that decision, that is also a correct decision, and it is measured like with probability 1 minus beta, and it is actually the true positive. Now, in this particular case where the null hypothesis is false, so that means you have to accept the alternative hypothesis, but in that case you fail to reject null hypothesis, means knowing that null hypothesis is actually a false thing, then you are failing to reject it, you are accepting it in that way. So, then you will making a type 2 error, which is also referred as a false negative, and then the probability is beta, right. So, in short, we can make two right decision in this matrix when we have null hypothesis or H0 is false. So, obviously, we have to reject it, and when you are making that decision it is a correct decision. When your null hypothesis is true, then ultimately in that case you have to accept that, and then you fail to reject that particular hypothesis, that is also a correct decision. In two cases you are making wrong decision, in one where the H0 is true, but then also you reject it knowing it is correct, you are also rejecting, that is type 1 error. The other one where the hypothesis null hypothesis is proved to be like false, then also you are accepting or failing to reject it, then it will type 2 error. If you understood that concept, let us take this example. Imagine a researcher is investigating the impact of natural light on occupant well-being in an office building. So, in this case null hypothesis is there is no significant impact of natural light on well-being, and alternative there is a significant impact of natural light on well-being. Now, out of your analysis this 4 possible statement can be made, right. Statement 1, the research conclude that the natural light has significant impact on well-being, but in reality it is not. Second one, where natural light has significant impact on well-being and in fact it is impacting. Third statement, natural light does not have any significant impact of well-being and in fact it is not impacting. Fourth one, the research concludes that the natural light does not have significant impact on well-being and when in fact it does. So, in all these cases let us understand where we are making this type 1 or type 2 error. So, how to do it? First you have to, because all the decisions are made based on the H0. So, H0 is having that no significant impact. So, we have to first find out those statements where it is written. So, no significant impact you have in this particular option C and also option D, right. So, in this particular case let us understand this. So, the hypothesis was no significant impact of natural light on well-being, and in this particular case it is mentioning that there is no impact and it does not. So, that means it is basically a true statement. So, in this particular case what should we do? So, this is basically we have to accept it. So, this is okay, this is also a correct decision. Now, at the same time we have another option that natural light has significant impact on well-being when it is in reality not. So, that means we actually have this option correct that okay, it is in reality it is not, but we are establishing the fact that it has the impact. So, that means we are arguing something which is not true. So, for that just take a moment and try to understand which particular error we are making here. So, if you look at this particular table like type 1 error, so what was the case that we discussed, that when the A0 is true, but we are rejecting it. So, here also you can see that in fact in reality it does not impact. So, that means A0 is true, but then our result concludes the natural light has significant impact. So, that means we are rejecting the null hypothesis, which is not the correct thing. So, here we are making in A is nothing but your type 1 error. Then next if we look at this particular option B, where natural light has significant impact and in fact it does. So, in this particular case what is happening, that this particular option you have both like this hypothesis which is not correct, right. In this case null hypothesis is not correct, and then you are having something that also support the alternative hypothesis. So, that means in this case you have to make a right call, right. So, in this case alternative hypothesis is true. So, in that case if we correlate with this particular table where you have this particular null hypothesis as a false statement because it is actually happening, and then you are also accepting in favor of the alternative hypothesis. So, you are also making a correct decision here. Now, we are left with the decision 4, where research concludes the natural light does not have any significant impact, but actually it does. So, in this particular case the A0 is false indeed, because it is making certain impact, but at the same time we are accepting this particular null hypothesis. Fail to reject means accepting. So, we are making type 2 error here. Now, the problem with this practical problem, when you go for type 1 error where you know that it does not impact and still you are proving it is impacting. So, for that architect may go for certain kind of installation, certain kind of design, and then to welcome those kind of natural light and all, and in reality if it is not impacting, so that means that will be wastage of resources. But at the same time if we go for type 2 error here, where actually the natural light is going to impact and we just make this particular decision that it is not going to impact. So, there is no need for natural lighting design in the architecture process. Hope this is clear. If you see that the statements are confusing, but if you just correlate with the table it is very easy, right. So, let us summarize this particular aspect here. So, we have discussed about the hypothesis, then hypothesis formulation, confidence interval, and then significance level, null hypothesis, alternative hypothesis, hypothesis testing process in terms of test statistics, or you can say the significance level, and then type 1 and type 2 errors, which are very important aspect, and we discussed with certain example. Just you need to thoroughly check those logical statement, and then you have to decide type 1 and type 2 error. So, we conclude here for this particular lecture, and we will move to our next lecture, which will be on parametric test. So, thank you for joining. We will be meeting in our next lecture. Bye bye.